Good afternoon, class. Thank you. You can sit down. Okay, today we'll be looking at the last part of graphs and curves, which is velocity time graphs. We are just going to look at the homework you were given. And then we will start a new topic, which is on sets. It's a new unit. So first of all, we'll look at the homework on velocity time graphs. All right, you were given questions 2 to 6, I think. So question 2, for each of the 4 speed time graphs, write down the acceleration or retardation. Okay, letter A. Who wants to answer letter A, please? Livingston. You have to say whether it's acceleration or retardation.
Acceleration 5 meters per second square.
Okay, it's an acceleration of 5 meters per second squared. Correct? Number 2, Vui.
Acceleration half meters per second squared.
I didn't hear.
Acceleration half meters per second squared.
Okay, half a meter per second squared. Correct. C, Jake.
Retardation of 1.5 meters per second square.
Retardation is 1.5 meters per second. Good. If it's acceleration, then it will be negative 1.5 meters per second. George, letter D.
Retardation of 2.5 meters per second square.
0.5.
2.5.
Are you sure? 0.5.
2.5.
2.5. That's better. Okay. Number 3. The speed time graph shows a vehicle traveling at a constant speed of 10 meters per second. Find the total distance traveled in 15 seconds. Is that part of the question? Is that part of the question? Okay, it's a separate question on its own. There. Find the total distance traveled in 15 seconds. Is that a different question? Does it have a graph? So this graph is not correct. But you can do it without a graph, right? Okay. Andrew, your answer for this question.
Total distance traveled is 150 meters.
150 meters. You just have to multiply 10 by 15 seconds. Okay, so what's the question for this graph? This one should not be here. Okay. Number 4 then. The speed time graph shows a car traveling with constant acceleration. What is the acceleration? Solomon?
The acceleration is 0.2 meters per second squared. 0.2 meters per second.
0.2 meters per second or 1 on 5 meters per second squared. All right, what is the initial speed? Gabriel Chakumai.
Meters per second.
4 meters per second. The initial speed is the speed when t is equal to 0. Gabriel Norambu, let us see. What is the distance traveled in 30 seconds?
The distance traveled is 210 meters.
10 meters?
210.
210 meters. You have to speak loud. 210 meters. All right, number 5, from the speed time graph, find the acceleration. Gabriel Narara. Was that planned? Okay, Gabriel Narara, your turn. The acceleration.
1 meter per second per second.
Does it, just wait, does it give the time for the acceleration? Okay, I think you know where to find the answer from the graph. Give us the acceleration then, Gabriel.
1 meter per second per second.
Say that again.
1 meter per second.
1 meter per second squared. It's 10 over 10. It would be the gradient of this line. Next question. What is the retardation? Velma?
3 meters per second squared.
Again?
3 meters per second squared.
3 meters per second squared. You all agree? Yes? Let us see the initial speed. Hekoi?
5 meters per second.
5 meters per second. Patrick? The distance traveled in the first 20 seconds.
250 meters.
250
50 meters.
meters. Correct? Good. Number 6. From the speed time graph, find the acceleration after 5 seconds. Megan,
1 meter per second squared.
the acceleration after 5 seconds. I want you to say that again, please.
1 meter per second squared.
1 meter per second squared is correct. The acceleration after 18 seconds. Esther,
2 meters per second squared.
10, 2 meters per second squared. Okay, that's 10 on 5, that's correct. The acceleration after 40 seconds. Margaret,
0.5 meters per second squared.
0.5 meters per second squared. And letter D, the maximum speed reached. Geno,
30 meters
30 meters
per second.
per second. And letter E, Siegfried, the total distance traveled in the first 50 seconds.
875 meters.
100 and
875 meters.
875 meters. Did you say that? 875 meters. You all agree? Siegfried has a question. Stand up and tell us what your question is.
The initial speed.
I didn't hear that.
Question 4B.
Question 4B. Do you want us to do that again? 6. Okay, question 4B. What is the initial speed? It's the speed that the traveler starts at. So it's when t is equal to 0. Initial speed, initial distance. In year 12, we do this in the introduction of calculus, and we talk about initial speed, and that's or initial velocity. That's when t is equal to 0. That's the speed that the person starts traveling at. Okay, so that's when t is equal to 0. We also talk about initial what is called initial position of a traveler. That's when t is equal to 0. Okay, any others? No? All experts. All right, then the next topic is sets. Since I started teaching, we have never taught this to the grade 11, so you are the first ones who are being taught this. We are also going to teach you 2 more topics which we think are relevant but are new. This is also not in the syllabus, but it's good for you. Well, I hope it is. Okay, the first question that I have, since you were asked to read, what do we mean by sets? Anyone? What do we mean by sets? Siegfried, in other words, define sets.
A collection of objects, numbers, ideas, etc.
Okay, it's a collection of objects, numbers, ideas, or it's a collection of anything. It doesn't matter what. All right, so that's what we mean by sets. Next question. What do we mean by, or what is a member of a set called? What is a member of a set called? Like, if we have a set of a group of people, let's say a group of students in 12P. All right, you're a set. And what is a member of a set called? Kila.
An element.
An element. All right, so a member of a set is called an element. How many sets are there? Or give me 3 types of sets that you've read about. The first one, Kyle.
A finite set.
A what?
A finite set.
Okay, a finite set, or if you like to call it finite, it's okay too. A finite set. Rita, define what a finite set is, so a finite set, spelled F-I-N-I-T-E.
A finite set is one in which all the elements are listed, such as, example, 3, 7, and 9 in brackets.
All the elements are
Listed.
listed. For instance,
3, 7, and 9.
3,
7 and
7,
9.
and 9, full stop, okay? So that's an example of a finite set where all the elements can be listed down. The second type of set, Boromeo.
An infinite set is one in which it is impossible to list all the members.
Okay, infinite set. Members are impossible to list. Okay, so infinite set is or has members that are impossible to, all of them are, it's impossible to list down. Okay, give me an example. Miriam?
One, 3, 5, 7, and etc.
Okay, that means the 3 dots means the set can be continued, or it goes on and on, or so on. You all know that from English. Okay, so it's impossible to list down all the members of all the elements in this set. All right, the third one, Tamaku.
Empty sets. Empty sets.
Okay, an empty set, or what's the other word? Null. Okay, an empty set or a null set. What is an empty set? Natasha.
Set which contains no element.
Okay, it's a set containing no elements. Okay, that would be called a null set. All right, I asked you to read from your textbook. Some of you had photocopied notes based on this. So I'll just go through that again. A set is a collection of objects, numbers, ideas, etc., etc. The different objects or numbers which form a set are called members or elements of the set. The elements making up a set are enclosed in braces or brackets, not just ordinary ones, but they have to be like what they're shown, okay? They're enclosed in brackets like this. And may be specified in two ways. Okay, the first one is by listing the elements. That's what we did here, 3, 7, and 9. We're listing the elements. Or the second way is by description. And I've got two examples on the monitor. Listing them, we can go 2, 4, 6, 8, and 10. But describing the same set, that's the set of even numbers between, it should go, the set of even numbers between 1 and 11. All right, I've got two of them. The next one is A, E, I, O, U. Or the elementary children might say A, E, I, O, U. All right, the set of vowels in the alphabet. So that's listing them and that's describing the sets. So there are two ways of specifying sets. Okay, the types of sets that we've put down on the board here. When a set has to be used more than once, a capital letter is used to denote it. Thus, we might write the elements of A, or the set A, consists of the elements 1, 3, 5, 7, 9, and 11. Okay, so the first type of set is a finite set or a finite set. A set in which all the elements making up the set are listed. All of them can be listed. And you've given one, I've got one that 1, 3, 5, 7, 9, 11. The other one, an infinite set, a set in which it is impossible to list all the elements. I've got set B, which has elements 2, 4, 6, 8, and so on. Meaning you can go up to 1 million because 1 million is an even number, and those are all even numbers. All right, a null set is a set containing no elements. It is denoted by this sign here. Okay, which is, if I can write it again on the board, a null set is denoted by this. It is not denoted by this. Okay, these are two different things. This is theta. We usually use that to denote an angle. This one we use to denote a null set. Or sometimes only this can be used. That means an empty set, or there's nothing in the set. Okay, the set of prime numbers between 8 and 11. Okay, are there any set of prime numbers between 8 and 11? The numbers between 8 and 11 are 9 and 10. 9 is not a prime number, 10 is also not a prime number. So if you say a set of prime numbers between 8 and 11, then that set is an empty set because it has no element. Clear? Okay, so that's what we mean by a null set. Okay, so is the set of whole numbers between 0.5 and 0.9. There is no whole number between 0.5 and 0.9. It's 0.5, 0.6, 0.7, 0.8, and 0.9, all the decimals, but no whole number. So that's a null set. Clear so far? Yes, you did all the readings, all the reading. Okay, the number of elements in a set is denoted by an n, and say for instance the letter that represents the set. Okay, so if the set A has elements 3, 5, 7, and 9, then the fact that 5 is a member is written as 5 is an an element, sorry, I'm reading from, okay, thus if A consists of the elements, set A consists of the element 2, 4, 6, 8, and 10, then the number of members, the number of elements in this set is 5. That's 1, 2, 3, 4, 5. Okay, so the n outside and the letter that represents the set will give the number of elements in the set. Is that clear? Okay? You're going to learn quite a few denotions in this topic, which is good. Now you will know what these signs mean when you see them. Okay, membership of a set. The symbol, this symbol, I don't know if it's clear on the screen. This symbol means a member of. Have you seen that symbol before? Did you know what it means? Okay, so the symbol means is a member of. So if the set A has elements 3, 5, 7, and 9, then the fact that 5 is a member is written as 5 is a member of A. Okay, so if I said something like this, a half is a member of R. R usually represents a real number. That means a half is a real number. Okay, so that's the shortest way of having to say half is a real number. The symbol, this symbol here, it means that it is not a member of. Okay, you can see there's something missing here, but it means, this one means an element is not a member of, or whatever it is not a member of the set. So because 4 is not a member of A, which is this set, then we write it as 4 is not a member of A. So this set, this means not a member of. Which means for the set that is on the screen, 4 is not a member of the set A. Okay, now you are going to do an exercise. Exercise 1, all you have to do, and we are going to do this orally, is to find out whether the sets are finite, infinite, or null. Which of the following sets are finite, infinite, or null? Number 1, is the set in number 1, is it finite or infinite or null? Agnes?
It's finite.
Okay, it's a finite set or a finite set. All right, number 2. Danielle, what do you think?
It's a finite set.
Huh?
Finite set.
Okay, it's also a finite set. Number 3, the set of points on the circumference of a circle. The set of points on the circumference of a circle. Is it finite or infinite or null? Dan, what do you think?
Infinite.
Infinite? Why? Can points on the circumference of a circle be listed? Can they be listed? Yes? Can they be listed? Gabriel says yes. So if they can be listed, then it means it is a finite set. Who says they cannot be listed? Who thinks they cannot be listed? Daniel thinks they cannot be listed. Boromir, what do you think? Not sure. Garanama, what do you think? A set of points on the circumference of a circle. Okay, let me just explain. When you go to grade 12, you will actually plot circles. You will be given equations, and when you plot the graphs, they will form circles. Which means depending on the equation of the circle, see the points will actually be on the circumference, because to be able to plot, you'll have to be able to plot the points to form the circle, and that's on the circumference. Which means they can be listed. Just like you plot straight lines and parabolas and hyperbolas, you will also plot circles. Number 5, the set of even numbers which can be divided exactly by 3. Kiapin, give us the answer to that question.
Infinite set.
Infinite set. Okay. Number 6, the set of odd numbers which can be exactly divided by 2. Raylene.
Null.
It's a null set, or it's an empty set. Number 7, the set of planets in the solar system. Lester is very quiet, so he's 10.
Finite. Finite set.
Infinite set?
Finite.
Finite set? Yeah, because you can list all the planets in the solar system. Garonamo, the number of people that have swam the Atlantic Ocean.
Infinite set.
Infinite set?
It's a null set.
Null set. Why do you say it's a null set? Do you know if people have swam the Atlantic Ocean, the whole, huh? It says the number of people that have swum, that means they have swum the whole Atlantic Ocean. How big is the Atlantic Ocean? Very big. So, I don't think. What about that marathon swimmer from Australia? Did she swim the Atlantic Ocean? 1% talk, please. Peter, give it to Peter. What do you think? Yeah. Do you think anyone has swum the Atlantic Ocean?
Yeah, it's too big, and no, I don't think somebody has ever swum it.
Yeah, I don't think anyone has ever swum the whole Atlantic Ocean. First he said someone has. So this one is a null set. Go and find out and see how many people swam the Atlantic Ocean. Number 9, if A has the elements A, B, C, and D, what is the number of elements in the set? What is n of A? Dan.
4.
4. Okay, the set has 4 elements. Number 10, B has those elements that are listed. Write down the value for I mean, tell me the value for A again. It can't be A. It has to be A. Well, if it's like that, then the answer is nothing, because I typed down, write down the value of the number of, it's got A again. It shouldn't be A, it should be B. And the answer is 10. Okay, the number of elements in the set is 10. Exercise 2. In the following sets, one of the elements is incorrect. Rewrite the set correctly, or what we will do is identify the element that is not supposed to be in the set, and then state using the set notation the element which is not a member of the correct set. Okay? What I want you to do is you are going to come up to the front, and then you are going to identify the element which is not supposed to be in the set, and then you are going to write using the set notation, meaning you're going to write like this. That's what we mean by set notation, the element which is not a member of the set. So the first one, could we have we, please? Number 1. You'll have to say which member is not which element is not a member of the set, and then write.
For number 1, 7 is not a member of the set. For the first one, 7 is not a member of the set
Why?
because it's an odd number.
It's an odd number, okay. Right in the middle, right at the top. And number 1. Number 1, okay. Okay, good. Number 2, who wants to do number 2? Livingston?
For number 2, 18 is not a set of Q.
I forgot how to pronounce it. I have to find out how it's pronounced. All right, next one. Number 3, let's have a girl. Hekoi. Number 4 will be Megan. You have to say why 9 is not a member of the set.
Because it does not decrease by 3.
She said because it does not decrease by 3. Okay, all the numbers in set number 3, to go from 1 to the next, you decrease the number by 3. 11, you decrease it by 2, and it will give you 9. So 9 is not a member of the set. Quick, Megan, you're next. Number 4, Andrew. Sorry, number 5. It'll be Andrew. Just call it a sign.
The sign is not value member of S because letter of the alphabet.
Okay. Number 5, Andrew. We'll make this the last one.
25 and 29 are not members of T because they do not increase by 2.
Are you sure it's 9? Okay, we add 4 to 5, we get 9. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 4 is 17. 17 plus 2 is 19. 19 plus 4 is 23. This one should be 23 plus. Because you see, this is 5 plus 4, then 9 plus 2, then 11 plus 2. Okay, so you're adding 4 here and adding 4 here, and then adding 4 here, and then suddenly you're adding 6. So which one is not supposed to be in the set? 29. 29 or 9? 4 and 2, 4, 2 and 4. I think 9 is not supposed to be in the set. Huh? All of them are prime numbers. Yeah. So 9 is not the one. 9 is the one that is not supposed to be in the set. Okay, let's see if there are 1, 2, 3, 4, 5 more questions for you to do for homework. That's on exercise 2. State which of the following statements are true. That's for homework. All right, the keyword to the pilot teacher is sets. Good afternoon, class. Thank you.
I am saved.